Hi everyone, and welcome to the Group 9 Senior Design Project. Our project sponsor was Yukon Information Technology Services and focused on their development and IT operations pipeline for quality financial systems, also known as KFS. KFS is a suite of financial software built on open source platforms for higher education. The ITS DevOps team manages and modifies the KFS environment by tracking issues, programming features, and then deploying these features using a pipeline.
So what is a pipeline? A pipeline is a series of steps that are automatically done to prepare code, test it, and deploy it to an environment. The pipeline begins with code in a central repository and an automated job that then compiles, builds, and deploys the updated repository to an application server. The goal of this project was to enhance this pipeline to include unit and integration testing, issue tracking, artifact management, and automation on a different orchestration tool called Atlassian Bamboo. These changes would deploy code versions in a more stable manner, as well as automate the entire process to faster deploy and/or troubleshoot upcoming changes. Our sponsor's motivation behind this project was to merge technologies within the Atlassian suite, though some other open source technologies were also integrated within this pipeline. Merging functionality across Atlassian products allows the DevOps team to more comfortably connect and manage their code pipeline.
What you see here is a DevOps team's previous pipeline. A developer has modified code and wants to deploy their changes to the application server. The first step is to commit and push their changes to the Bitbucket repository. Pushing to the repository would then trigger a job in Jenkins, an automation orchestrator. Jenkins would then compile, build, and deploy the code to a Tomcat server, also known as the application server.
Here's the final version of the pipeline, which runs similarly to the original but with different technologies. In this pipeline, a developer has modified code and wants to deploy their changes to the application server. The first step is to commit and push their changes to the Bitbucket repository. Pushing them to the repository will then trigger a job in Bamboo, an automation orchestration tool similar to Jenkins, which is the heart of the pipeline. Bamboo will simply compile, run unit tests, build, run integration tests, and deploy the code to the Tomcat server.
We first started the project by creating a plan in Bamboo, which runs stages sequentially to perform a source code checkout, a Maven release, and manage artifacts on a development server. As part of the project build process, we created triggers to run jobs when developers push code to the repository, as well as set up email alerts to notify developers when the pipeline fails or passes for a certain repository's branch. We then implemented this plan for the production KFS environment. In our next phase of this project, we then created unit tests to add to the DevOps team's unit testing suite. Additionally, we researched and added functionality to allow developers to select the release version of builds in Bamboo. We also researched code coverage tools and tested Atlassian Clover for Eclipse, which is a tool for developers to test how much of a code repository is covered by unit tests. In our latest phase of the project, we set up an OpenShift container and ran a build within the container. Once the build completed, Bamboo would run an integration test within that container. A successful integration test within the container would determine if the pipeline in Bamboo fails or continues. Next, we'll look at a demonstration of the pipeline.
When the pipeline is triggered, it begins the first task of pulling the updated code from Bitbucket. After performing this source code checkout, a build automation tool called Maven is used to generate a package of the application. Now that we have an updated package of the application, the pipeline runs integration tests to ensure there are no bugs in the new code. If even a single test fails, the pipeline build will be halted and a notification will be sent out to the developer who pushed the most recent code changes. Otherwise, if all the tests pass, the pipeline stops the currently running application and removes the old package. It then copies in the new package and starts the application back up. Lastly, an automated health check is performed to ensure the application is accessible on the server.
In conclusion, we'd like to thank the University of Connecticut School of Engineering, as well as our faculty sponsor, Professor Yufeng Liu. We'd also like to give a big thank you to our sponsor, Yukon Information Technology Services, and our sponsor advisor, Richard Ritchie, for giving us the opportunity to work on this project. We very much enjoyed the work and support given by you and your team. And on behalf of Group 9, we'd like to thank you for taking the time to watch our presentation and hope you enjoyed learning about our project as well.